Hey gang, Tom and Mark here to do a 1-point ORP standardization. What we're going to do today is take a brand new sensor, clean, rinse it, dry it off, and then place it in our ORP standard, program the analyzer, and then have it ready to go. ORP stands for oxidation or reduction. It's a type of reaction. An example of that is when you add chlorine to water, you are oxidizing agents. That generates a millivolt signal. When you add sodium bisulfite to water, you can reduce the level of chlorine. That too gives off a millivolt signal that a sensor can pick up.
So ORP is essentially, this is a voltmeter for the water.
Correct.
Okay, great. Well, I got a couple of questions for you then. What standard solution should I use?
There are multiple standard solutions available. Because we're doing a single point standardization, what you want to do is pick one of those standards that is closest to the set point where your reaction is going to take place. In this circumstance, we have a 300 millivolt solution.
Should I choose a manual standardization or automatic standardization?
We prefer to use a manual standardization. As probes tend to be used and wear out, they tend to respond slower. Automatic calibrations are software sequences that time out after a certain point. Manual calibrations, you can be a little more patient and wait for the sensor to adjust to the standard.
Okay. Now I noticed that this sensor looks a lot like a pH sensor. Is it affected by temperature the same way pH is?
No, ORP is not affected by temperature, but from a practical standpoint, if you've had this sensor in an elevated solution, like a plating solution, for your own safety, it'd be good just to pull it out and let it cool down.
Okay. So you want to talk me through the procedure again? What are we going to be doing?
Sure. What you're going to be doing is a single point standardization. So you'll pull the probe out, clean, and rinse it.
Okay. So we're going to do that here. Okay, now if I had buildup on there, well, like with a pH sensor, you'd use like a dish soap and soak.
Correct.
Soak
if there's
it for a
some
time.
sort of material buildup on there, you can use some dish soap and water to clean it off, and then rinse it. Maybe even a soft bristle brush like a toothbrush, and just lightly go over that. Then rinse it and dry it off. And then you can place it in your 1-point standard solution.
Okay.
Allowing it time to adjust to the standard.
Okay, so we're going to get into the calibration menu here. And there you have it. So now that we're standardized, the sensor is cleaned and then placed back into the process. So a couple more questions, Mark. How often should the system be standardized?
That's going to depend on each and every process. What I recommend is you start with once a week, pull the probe out, clean and rinse it, and place it in your standard solution. If you're within plus or minus 20-25 millivolts of your process standard, then you should be good and move on to the following week.
So no need to re-standardize at that point?
Correct.
Okay.
If you're more than that, then you'll want to redo a single point standardization. As your probe ages and is used, you'll determine that if you can extend that time frame out to maybe once every 2 weeks to once a month, based on how often you have to redo the standardization.
What type of applications can we use ORP measurement?
ORP can be used in a variety of applications where you're adding an agent to create a reaction of some sort. Commonly used are adding chlorine into drinking water where you're oxidizing or killing something. You can also add sodium bisulfite to reduce, to take out chlorine, like on reverse osmosis membranes. Also in plating, wastewater treatment, as well as municipal and industrial food wastewater treatment. There are applications.
Well, thanks for that, Mark.
And there you have it, gang. A 1-point standardization of an ORP system. If you have an application for ORP that you'd like us to review, please give us a call. We'd be happy to help you out.